Good evening everyone. Today we are going to do the daily Leetcode challenge of 10 February 2023. That is question number 1162. As far from land as possible. So question is saying we are given a n cross n grid which contains only 0 and 1 values. 0 represent water and 1 represent land. We have to find a water cell such that distance to the nearest land is maximized and return the distance. If no land or no water exists, then we return -1. That is our corner case, you can say. Now they have given that we can travel in Manhattan distance. Manhattan distance means we can either travel horizontal or vertical. Diagonal movement is not possible. That is what Manhattan distance means. So without further delay, let's move on to the examples. So in the first example, what we can see, we are given water and we are given land, and as it is Manhattan distance, that is we can either move vertically or either move horizontally. We cannot move diagonally, and we have to find maximum distance for nearest land, maximum distance for nearest land. So it is 1 and it is 2. So 2 is the answer. We cannot move diagonally. Also we cannot do this 1, 2 and 3. We cannot do this because the nearest land to this water is this. So we have to find maximum distance for the nearest land. That's why this middle one is 2 steps away from everyone. So answer is 2 in this case. Let's see another example. In the second example, what we can see, there is only one piece of land. So we can move 1, 2, 3, 4. So answer is 4. Or we can move 1, 2, 3, 4. Or we can move 1, 2, 3, 4. So these are only possible ways and answer is 4 in every case. So we have to find maximum distance for the nearest land. So how do we actually approach it? So the first thing which should click in your mind when you see this question, that you have to traverse in a grid. Grid is of size n cross n, that is n square. That is one is row and one is column. So if you apply BFS, you can do it. You can traverse every distance and you can return the distance, maximum distance you found for the nearest land. But the BFS itself has n square complexity, and you have to apply BFS for every column or every element of the grid. Then it will be n square into n square, that would be n4. That would be a very huge complexity, so that would not be possible for this case. So to avoid such confusion, we use multi-source BFS. What is multi-source BFS? That means we will start BFS from every land, or we will start BFS at multi-sources. In this case, we will start BFS from every land. 1, 1, 1, 1. So we will start BFS from multi-sources possible. Let's see it in another example in detail. So what we will do for multi-source BFS, MBFS, let's say, what we will do, we will start BFS from here. We will iterate its neighbor. These two are iterated. Also, we will start BFS for this. It will iterate its neighbor, but it will not iterate this because it is already visited in BFS. Same goes here, it will iterate it. And same goes here, it won't be able to iterate anything. Then also before that, we will also be iterating for its neighbor. So ultimately, any of these paths will lead us to this middle one, which will be of distance 2. We will make a variable distance to store our distance. That is distance plus plus will give us the distance needed to travel. And why it is multi-source BFS? Because we are already pushing all the lands that is 1 points in our queue, and then we are starting our BFS. So all the paths are observed, consequently that it will end it only in BFS of n square complexity, and n square would be the minimum time complexity. As it is grid, you have to iterate for the column and the rows. That is how you can give the answer. Also, we have to check for the border cases, that is, if there is no land or no water, we will return -1. So we will see it in the code. So the overall approach is we have to apply multi-source BFS, that is we will start BFS from multi-sources and we will return our distance. Let's see it in code. Let me just zoom it for you. So if you understood the overall approach and you know BFS, this question will be easy for you. We will start with creating a variable int n is equal to grid.size. Because it is an n cross n grid, we can directly take the n for both rows and columns. Then we will make a queue of pair. Why pair? Because we have to store rows and columns both to get the position. Pair int comma int, let's name it as queue. Now after that, what we will do, we will mark the lands and push it on our queue. That is how we are starting it as multi-source BFS. So for int I is equal to 0, I less than n, I plus plus. For int j is equal to 0, j less than n, j plus plus. Then if grid I j is existing, then we will push it in our queue. Q dot push I comma j is pushed. You can either write this or you can write it as grid ij is equal to 1, then we push it to our queue. That is, every land position is pushed. After that, you have to return our answer. That is, int answer or distance you can say will be 0. Initially it is 0. After that, what you will do, you will apply our BFS. This step is pushing all lands into our queue. Why pushing all lands into our queue? So we can start our multi-sourced BFS. Now, how will we actually start BFS? So BFS format remains same. We will write while queue is not empty. Well, queue is not empty. We will make a variable int size equal to queue dot size, and then we again write while queue is not empty. Oh, sorry. While size is decrementing, we will reduce the size, and then we will write auto queue dot let's say temporary variable is equal to queue dot front. That is, front element is taken, and then we are popping the front element from the queue. Queue is first in, first out. That is, first person to come will be first served out. So front element is taken and then it is popped out. After that, what we will do, as we have to check the 4 direction possible, that is, one is above, one is below. That is what I mean is, we can either move one steps above it +1, or below it -1, or if you move here, that is another +1, or here another -1. So we have to iterate in 4 direction. So for that, we will make arrays. You must have seen this in number of islands question. It is a typical question and it is generally used in BFS, so you should be knowing about it. That is -1 1 0 0, and int y is equal to 0 comma 0 comma 1 comma -1. And now we will check whether it is valid or not. What I mean by valid is, if we are at this step, we cannot move to its left. So we have to write condition that whether the movement is possible for the BFS or not. So for that, we will write if. You can make another function if is valid, or you can write it here, that is if. Before that, let's run the loop. For int I is equal to 0, I should be less than 4 because there are 4 directions possible, and I plus plus. We will get the row, int row is equal to, that is temp dot first, that is the row, and we will add our possible movement, that is x of I, that is whether it is possible to move there or not. We will add that, and int column is temp dot second, that is second, plus y dot I. This will give us the column. And now what we have to check, now we will check the condition whether it is valid or not. How we will check it? If row is greater than equal to 0, and row should less than n. Also, column should be greater than equal to 0, and column should be less than n. And we have to check whether grid of row, the new coordinates, is water or not. We have to make sure that it is water. And if it is water, we will mark it visited. How we will mark it visited? We will write grid row column is now visited. Simple. And now what we will do, we will push it in our queue so we can further do BFS calls. And when this whole process is done, and after this, if our queue is still not empty, until the queue is completed and we have reached the end of the BFS, we will increment our distance. That is, we are moving one step every time. And after that, when we are done with this, we will check if distance is still 0, that is all our water or all our land, then we will return -1. If this is not the case, we will return our distance. This is all you have to do. Let's check whether it is working or not. We have written k, it should be 4. Temp, there should not be these brackets. So yeah, it is running, and let's submit it. So yeah, it is accepted as well. So the time complexity in this case is O of n square of BFS, and space complexity is also O of n square, as we are storing it in a grid. Also, as we are making changes in the grid itself, that's what we are doing. So that is all you had to do. I hope you liked the video. Please like, share and subscribe. Thank you so much for watching. Bye bye. If you have any doubts, comment down. Bye bye. Bye bye.